Hi, I'm Sammy. I'm the CEO of Eventual, and I drink espresso with a splash of almond milk.
And then coming back to what you're doing with Daft and how you're thinking about that, how does that tie in?
Yeah. So a lot of these use cases, like, for example, Harvey might do is they have these corpuses of legal documents, and they want to be able to get these documents, use image processing on them, extract out text, and then run them through LLMs. Those are things that Daft would be a really, really good tool. What we see right now in the generative AI space is that a lot of people are just writing Python scripts that go over each file, extract the text manually, and then hit the OpenAI API. And they kind of then dump that either in a file or like one of these vector databases. And then kind of the process completely restart once they switch the model or switch the kind of thing that they're doing. And so we want to make that really easy to do, which is I can build my entire pipeline just using a data frame like I would do for pandas. And when you're ready to commercialize it or make it production ready, you just switch a couple flags and then you can run this on a cluster. So it makes their life a lot easier is what I would say.
Yeah. Oh, dude, I see the vision then. I see and I understand that. So one thing that I also wanted to mention and bring up is, and you kind of hinted at this before, is around how you think about the needs and trade-offs when it comes to tabular data versus this unstructured or complex data, and certain things that you need in tabular data and other things that you need in complex data, and how you look at the two architectures. And if you're setting up a system right now and you only need to go down one route, maybe it's the tabular data route, then what are you going to be building for and optimizing for? And then if you have complex data, what are some things that you're keeping in mind and optimizing for?
Yeah, that's a good question. I guess like talking about the axioms of both, I think is really important. So when we talk about tabular data, you typically think like integers, floats, things like strings. And most of the time when you have this data, the queries you're running are usually aggregations. So what that means is that I have like these files of text. They could be large files of text. And what I'm essentially doing is going through each row and then doing things like min, max, sum. These very cheap operations to compute. So if you think about it as what is the volume of data I have and the volume of compute, it's actually much more data heavy. So it's like I might have gigabytes of data, but I only have, billions of operations. So they're quite balanced. But let's talk about an image. Images and things like text for LLMs is completely different. Whereas if I have like a 100 kilobyte image, I'm processing potentially trillions of operations on it. Right? Or if I have like, let's say a work of Shakespeare, which is only like a megabyte, I will be processing, quintillions of operations using an LLM. And so the ratios that we think about of compute over the data is completely different. So when you're building complex systems, you have to think about it as I will be compute bound almost every single time. Whereas like if you think about traditional query engines, you're like, okay, all they're doing is optimizing for, reading from S3 and they don't really bother about the compute. Which is fair because they're going to be bottlenecked by
that. So then what are some, I love you break it down by the axioms and you think about, hey, let's look at the fundamentals of one versus the fundamentals of another and what the bottlenecks are going to be and what you're going to encounter. And so then as you're building systems around this, what are some things that you would say, I definitely want to have in my toolkit if I'm dealing with one versus the other?
Yeah. I would say if I was building an analytics engine, I would go for something simple and something that failures are handled in a way where we can recover easily. So for example, like if you're running things on like a Spark cluster and it's fine because the amount of work you have to reproduce is not bad. Okay. But if you talk about that in terms of like a complex data cluster, that does not work very well. And so what we're building around that is first making sure Daft understands the data types natively. So they understand what an image is and how expensive it is to bring into memory, how expensive is it to send it around, and also for these various other formats as well. Also understanding that placement and scheduling is very important, and we require really high utilization. So an example is if you get a lot of these complex data workflows and map it to something like a Spark cluster, you only use about 20% of the hardware.
Okay.
And so if you're using GPUs or, you're running LLMs or a computer vision model on this data, you're pretty much burning 5 times more money than you have to. And so some of the things that we're doing here is saying, okay, you know what? Our users are typically enterprise companies who want to save money. And by porting things into Daft, they can run things that's, Pythonic using data frames, but then still get really good utilization and cheap throughput, essentially, for their whole system. And so, yeah, the things we're designing around there, once again, are really understanding the data we're working with, having query plans that are necessarily not optimized for tabular analytics, but for complex data processing, and actually being really tied into the hardware we're running on. So really understanding the AWS machines we run on and how to get the most out of them, built into the framework.